Math 110, Solving Exponential Equations, Sections 5-5. The first property is the base exponent property. When it says that if I have two of the same bases to whatever powers they are, I can say that the powers equal each other. So a to the x equals a to the y. I can make the statement y equals x. So in this one, 2 to the 3x minus 7 equals 32. Using this property, I want to try and make my bases the same. And so I can rewrite that 32 as 2 to the 5th power. Now that my bases are the same, I can say my powers equal each other. So from there, all I need to do is solve. I can add 7 to both sides, divide both sides by 3, and so I'm going to get the value x equals 4. So let's kind of verify that. If I take this 4 and I plug it back in, I'm going to get 2 to the 5 power, or 2 to the 5th power. Well, that's going to equal 32. 32 equals 32, so I know it's going to work. The other property that we're going to be using is called the property of log equality. Now what this says is that if I have a log of the same base and I have some m equals n, I know that those values are going to equal each other. And we're going to kind of have to use that analysis a little bit for us to be able to kind of like simplify or at least find these common logs to each other. And it allows us to do this manipulation I'm about to do. What I want to do is, because there's no possible way here that I can find a common base. There's no way I can turn this 20 into 3. I want to take common log to both sides. Now that phrase common log, all that means is log base 10. It's the log that we get into our calculator. And so now that I've taken common log, this becomes that power that I can move to the front using the power property. And so moving that x to the front, now that it's no longer an exponent, I can manipulate my equation to solve it. So now I'm going to divide both sides by log base 3. Just log 3. And so in my calculator, I enter log 20 over log 3, and it's going to give me approximately 2.7268. On this next one, before we apply this property where we take log to both sides, you want to make sure that there's nothing in front of it. So I don't want anything in front of my e. So I'm going to divide both sides by 100. And so I get e to the 0.08t equals 25. Now to cancel out that e, I want to take ln to both sides. So now ln and e will cancel out, and so I get 0.08t equals ln 25. Divide both sides by 0.08, and so I'm going to get t equals ln of 25 over 0.08. That simplifies into 40.2. On number 4, same type of concept, just a little bit more complicated. So there's no way I can make 4 and 3 into the same base, so I take that common log to both sides. Now, because this is that property, I can take that x plus 3, and then I can take my negative x and I can move it to the front. If I distribute this log 4 to both of those, I'm going to get x log 4 plus 3 log 4. Now, it still is kind of abstract because I have x's here and I have here. It's not like I can just add them together and combine them. It's a little bit more abstract than that. And so when we do that, we have to use the analysis of what's in common. So I want to bring all of my x's to one side, bring everything else to the other side. And so I'm going to add x log 3 to this side, and I'm going to subtract 3 log 4 to that side. So they cancel out like that. And so I'm going to get x log 3 plus x log 4. So x log 3 plus x log 4 equals, since those canceled out, I'm just left with negative 3 log 4. So like I said, we can't combine these together, but I can look at through the lens of what's in common. And in this case, x is in common, so I can factor out an x. And so if I factor out that x, I'm left with log 3 and log 4. I can divide both sides by log 3 plus log 4, and so I'm going to get x equals negative 3 log 4 over log 3 plus log 4. Entering that into my calculator, I'm going to get negative 1.6737. On this problem here, e to the x plus e to the negative x minus 6 equals 0. So the first thing, I got to try and maybe find some way I can add these together, because right now they can't, because that's x and that's minus x. So maybe if I make this into a positive x, right, by flipping it over the axis, maybe I'd be able to do something there. Well, still, once I did that, it's kind of like, how do I combine that together? How do I do that? Maybe if I combine or find the common denominator, maybe I can add everything together. Maybe we can try that, because having an x in the numerator and having an x in the denominator isn't going to help. So let's get that x out of the denominator. So I need to multiply this by e to the x over e to the x, this by e to the x over e to the x, and this by e to the x over e to the x. And so now that all the denominators are the same, they're all going to cancel out. And so e to the x times e to the x gives me e to the 2x. Now this is minus 6 e to the x, and then I have my plus 1. And 0 times e to the x is just 0. Now this looks like that quadratic type, right? This is a square, non-square, and then a constant. So I can say that u equals e to the x. And so I substituted u in there. Now sadly it doesn't factor. If it did factor, it'd be so much nicer, but it doesn't. So instead I have to use the quadratic formula. So I have to do negative b plus or minus the square root of b squared minus 4 times my a times my c all over 2 times a. And so I get this statement here. And so now I want to be able to simplify this. So this is going to, if I simplify this, this is going to turn into 3 plus or minus 2 rad 2. But I'm not trying to find u. What I'm trying to do is I'm trying to find what my x is. So now I can substitute u in for e to the x. And so now this is an equation in which I can use logs to solve. And so I can take the ln of both sides. And so ln times e, that's just going to give me x, equals ln of 3 plus or minus 2x. And so this is going to give me ln of 3 plus 2 root 2, and then ln of 3 minus 2 root 2. Those I can enter my calculator, and I get x equals 1.76 and negative 1.76. Now in this example here, we're going to be solving logs. So in the previous lesson we talked about how logs and bases canceled out. And so what I want to do to get rid of a log is I want to take whatever the base is of that log to make it cancel out. So since this says log base 3, I want to take base 3 to both sides. And so the base 3 and the log base 3 are going to cancel out. And so I'm going to get x equals 3 to the negative 2. 3 to the negative 2 is the same as 1 over 3 squared, which is the same as 1 over 9. Now because logs have domain restrictions, there's a possibility for extraneous solutions. So that means I have to take my answer and I have to plug it back in and check for extraneous solutions. So taking my 1 over 9 and plugging it back in, this log base 3 of 1 over 9, that turns into log base 3 of 3 to the negative 2. Those cancel out, and so I'm left with negative 2. Negative 2 equals negative 2, so I'm good. On this next one, I can't just take base 10 to cancel that out, base 10 to cancel that out, base 10 to cancel that out. It doesn't work that way. You're taking it to the entire side, so our log has to be grouped together. And so our last lesson, we learned about the properties of logs and how if it's a plus, we can represent these as products of each other. And so I can reduce this, or I can combine this together and say this is log of x times x plus 3. So now I can take that base 10 to both sides. Log and base 10 cancel out. I can distribute that x through, and so I'm going to get x squared plus 3x. This was 10 to the first, so that's going to be 10. Minus 10 on both sides. So I get x squared plus 3x minus 10 equals 0. I can factor that, and so I'm going to get x equals negative 5 and 2. Now you probably thought we're done. We're not. We have to check for extraneous solutions. So checking the first one, if I plug in negative 5 into my equation, I get a negative inside of my log. That contradicts what my domain is. I'm not allowed to have a negative inside of my logarithm. Therefore, it can't be an answer. Okay, so we have to cross it out. It can't be one of our values. So now testing 2, I get log base 2 plus log 5. I can represent these as products. So I get log 10. Well, those are going to cancel out into 1. So I want to equal 1, so therefore it works. So once again, this log base 3 of 2x minus 1 minus log base 3 of x minus 4, I want to represent this as a single log. So I'm going to use my quotient rule. And so this was positive, it's on top. This had the minus, so this is on the bottom. And so I get log base 3 of 2x minus 1 over x minus 4. Now I can take base 3 to both sides, so those are going to cancel out, and so I'm left with 2x minus 1 over x minus 4 equals 3 squared, which is 9. So now getting x out of the denominator, I multiply both sides by x minus 4. So the x minus 4 and the x minus 4 cancel out, and so I'm going to be left with 2x minus 1, distribute that 9 through, and so I get 9x minus 36. Now I'm just solving for x. Add 36 to both sides, subtract 2x, divide by 7, and so I get x equals 5. Now I have to check for extraneous solutions. Plug that 5 back in. And so if I did that, you get 10 minus 1 over 5 minus 4. Now I plugged it into this one, and the only reason why I did that is because if I plugged into this, I'm going to have to move it down to that step anyways. And so you get 10 minus 1 over 1, which is the same as log base 3 of 9, which is the same as log base 3 of 3 squared. The 3's cancel out, which give me 2, and so I get 2 equals 2, which is my answer. This next one, you can do the same thing even though it's ln. So I can represent this as a single logarithm. This is positive, it's on top. This is negative, so this goes on the bottom. Now I can take base e to both sides, and so those are going to cancel out. And so I'm going to be left with 4x plus 6 over x plus 5 equals x. Once again, multiply both sides by x plus 5 so that it cancels out here. I can distribute that there. And so I get 4x plus 6 equals x squared plus 5x. Now I can bring everything to one side. So I can subtract the 4x, I can subtract the 6, and so I get 0 equals x squared plus x minus 6. Now I'll factor it. So that's going to turn into x plus 3 and x minus 2, and so I get negative 3 and positive 2. If you thought you were done, you're wrong. Now I have to check for extraneous solutions. So I have to plug the negative 3 into the original equation. Okay, and so if I simplify that, I get a negative inside my log. Can't have that, so it's not going to be an answer. Now if I try 2, I'm going to get, this is going to be 14. This is going to simplify into 7. And so I can represent that as 14 over 7. And then that's going to be ln of 2 because 14 divided by 7 is 2. And so they're going to be the same. So that's going to work. If you have any other questions, please leave them in the comments.